Welcome. Today we are pleased to present the Strategic Roadmap for Data Classification, a comprehensive implementation guide based on NIST Special Publication 1839. This work stems from the National Cybersecurity Center of Excellence Data Classification Practices Project, aimed at helping organizations better understand and manage their data assets. As shown in the illustration, our goal is to bring order to complex data streams by housing them within a secure, structured framework. Please be aware that this presentation covers the initial public draft, and your input is vital to our process. We invite you to share your feedback before the comment period concludes on March 30, 2026. Let's dive into the core strategies for effective data classification.
The graphic before you illustrates a critical challenge facing modern organizations: the massive volume of unstructured data. While structured data found in databases typically represents only 10 to 20% of an enterprise's digital footprint, the remaining 80 to 90% consists of unstructured content, such as documents, emails, and PDFs. This hidden mass is often referred to as dark data because it remains unknown, unmanaged, and invisible to traditional oversight. As noted by NIST, the primary organizational risk lies beneath the surface. Without proper classification, this data cannot be effectively protected, migrated, or utilized, posing a significant hurdle for both security and operational efficiency.
Classification is the fundamental prerequisite for modern security and the essential foundation for adopting emerging technologies. To understand its importance, we must look at how it enables three critical pillars of current and future infrastructure. First, within a zero-trust architecture, the concept of never trust, always verify relies entirely on knowing what we are protecting. Data must be accurately labeled so that access can be dynamically authorized based on its specific sensitivity level. Without this classification, a zero-trust model cannot make informed, granular decisions about who should see what. Next, as we integrate artificial intelligence into our workflows, data classification becomes a safety requirement. AI model training requires clean, labeled datasets to function reliably. By classifying our data, we ensure that models are trained on appropriate information, which helps maintain safety and prevents the risk of model poisoning. Finally, we must look toward the future with quantum-safe cryptography. As quantum computing advances, we face the massive task of updating our encryption standards. Classification allows organizations to take a risk-based approach, prioritizing these vital encryption updates for their most sensitive assets first. Ultimately, data classification is the foundational dependency that allows us to navigate and secure the evolving technological landscape.
To validate our proposed practices, the NCCOE collaborated with industry leaders to build the functional lab environment shown here. Our primary goal is to demonstrate the complete lifecycle of discovering, identifying, and labeling data across network file shares and endpoints. The architecture centers on a synthetic data host, which serves as the data repository for the various testing environments. As depicted, this central host connects to distinct technology stacks from our partners: ActiveNav, JanisNet, IBM, Thales, and Trellix, allowing us to evaluate multi-vendor approaches to data visibility and governance in a controlled, realistic setting.
Our test bench is composed of 25,884 synthetic files, meticulously designed to represent a diverse array of data categories. As you can see, these include standard identifiers such as patient ID, name, address, city, county, state, zip code, and birth date, alongside more formal documentation like license and passport numbers. We also specifically included NCOE-specific identifiers for customer and billing information. To ensure the highest level of accuracy, the dataset utilizes a strategic mix of reactive sensitive files and non-reactive benign files. This allows us to rigorously evaluate the system's performance by monitoring for both false positives and false negatives, ensuring the solution is both precise and reliable.
The Universal Classification Workflow represents the standard of practice for unstructured data governance, applicable regardless of the specific tool or platform being utilized. This cycle ensures a consistent and repeatable approach to managing complex data environments. The process begins with defining the policy and schema, where the rules and categories that guide the entire classification effort are established. Once this framework is set, the workflow moves into the discovery or scan phase,
to locate unstructured data across the various storage environments within the organization. Following discovery, the next step is to identify elements. During this phase, specific content types and sensitive data points are pinpointed within the discovered files. This leads directly to labeling data, where the appropriate metadata tags are applied to formalize the classification. The cycle concludes with report and analyze. This critical final stage provides the visibility and insights necessary for risk management, compliance auditing, and evaluating the overall effectiveness of the data governance strategy.
Step 1 focuses on defining policy and schema. Conceptually, the foundational principle here is that you cannot find what you cannot define. Before implementing any technical solutions, it is essential to establish a clear framework for what your organization is looking for and how it should be categorized. On the implementation side, this translates into selecting the relevant regulatory and internal standards that apply to your data environment. This includes data protection regulations like GDPR, industry mandates such as HIPAA for healthcare or PCI DSS for payment security, and internal classification tiers ranging from confidential to public. By formalizing these policies and schemas first, you create the necessary roadmap for effective data identification and governance.
Moving into steps 2 and 3, we focus on discovery and identification. During the discovery phase, tools ingest file types, metadata, and content to effectively distinguish signal from noise. This scanning process is performed either via agents deployed on endpoints or through agentless network crawling across the environment. Once data is surfaced, we apply identification logic to categorize it. This involves pattern matching through regular expressions, keyword searches, and proximity analysis. For example, identifying an address based on its close proximity to a zip code.
In Step 4, we focus on applying persistent labels to the data. By utilizing structured schemas, such as privacy and health information, we can assign specific sensitivity levels ranging from low to high. This transformation ensures that files are no longer treated as opaque objects. Instead, they now carry embedded sensitivity attributes that travel with the data wherever it goes, providing a permanent layer of context and security.
Implementation logic centers on the precise configuration of the scanning parameters to balance detection accuracy with operational efficiency. As shown, we define specific custom match items, such as the NCCOE billing number and customer number, each with a set threshold to ensure high precision and reduce false positives. Additionally, we manage system resources by establishing a memory usage limit of 1,024 megabytes and an unlimited throughput capacity. This granular configuration is essential for maintaining optimal system performance and stability, even during the most demanding scanning operations.
Step 5 focuses on reporting and analytics, the stage where raw scans are transformed into actionable governance. By utilizing key metrics such as the full file catalog, sensitivity distribution, and identified policy violations, organizations can maintain a comprehensive overview of their data health. The dashboard illustrates our progress, showing that 65% of files have been successfully labeled, while 35% remain unlabeled. We also see a clear breakdown of sensitivity levels, ranging from low to high, and a list of specific at-risk files that need remediation. ePolicy Orchestrator facilitates this through configurable reports, allowing users to view, sort, and filter classification results to manage data effectively throughout its entire lifecycle. Our solution demonstrates proven capabilities across the broader data ecosystem through strategic integrations. For instance, ActiveNav's Discovery Center enables effective unstructured data mapping and cleanup. For automated discovery, we leverage IBM Guardium Discover and Classify. To ensure security for stored information, Faley's Cipher Trust Manager provides critical data-at-rest scanning. Additionally, Trellix offers comprehensive endpoint protection, both agent-based and agentless, through its DLP Discover and ePolicy Orchestrator. Finally, JanisNet provides specialized expertise in data classification, rounding out our robust end-to-end security framework. Data classification delivers a measurable return on investment by shifting the operational balance from risk to control. This transition is driven by 3 key factors. First, we minimize data loss through absolute visibility. Knowing exactly where sensitive assets reside allows for precision in security placement.
Second, we ensure regulatory compliance by establishing verifiable audit trails, which are indispensable for frameworks such as GDPR and HIPAA. Third, classification builds readiness for emerging technologies. It guarantees clean data for AI training and provides the high-fidelity signals required for zero-trust architectures. To effectively protect your data, you must first truly know your data. We invite you to join the conversation by reviewing the initial public draft of NIST SP 1800-39. Your feedback is essential to the success of this initiative, and we encourage you to submit your comments by the deadline of March 30th, 2026. For any questions or direct communication, please reach out to the project team at data-nccoe@nist.gov. You can access the guide and find comprehensive project information at nccoe.nist.gov/data classification. To further your understanding of the topics discussed today, we have compiled several essential references and resources. The upcoming NIST Special Publication 1839, Data Classification Practices, scheduled for release in February 2026, will serve as a foundational guide for implementing robust classification strategies. For real-time updates and detailed project information, I encourage you to visit the NCCOE Data Classification Practices Project page. Additionally, the Cybersecurity Framework 2.0 mapping is a vital tool for aligning your data classification efforts with standardized security objectives. These resources provide the technical depth and strategic context necessary to successfully implement and manage a data classification program within your organization.